जाने तो ना जाने जो जाने तो ना जाने तो जाने तो ना. Okay, so I'm taking out some time to record all my videos and notebooks because it's my daily big data code challenge that I have taken. And my last notebook in this CommonLit Kaggle competition, it was very big, and I created another notebook, and it is like how many students scored excellent. And the results from last notebook I have copied it in grades.csv, so you can check out my last notebook. And in my last notebook I have actually done feature engineering and cleansed and pre-processed the data, and I have shown how to group, filter, query, manipulate data, and also remove NA values, not null values, and all such kind of things I have done. And also I have made videos and uploaded in YouTube. So in CommonLit competition, we have things like data mostly about students, and the goal of this competition is to score and see what would be the content future score. And in this notebook and in this video I'll be explaining how outliers are removed, and what is the way to find outliers, and also explain to different kind of managers and different kind of clients, like what is variance, and compare the data and show statistical graphs, visual graphs, and also write summaries and profiler reports. So all that will be covered in this video. So stay tuned. Stay tuned. Yeah. I hope to make this video a little bit smaller. Unlike my last video, I had to delete my last video because it was too big, and I was explaining a lot of statistical methods and why I did that and this. So I'll keep this video short. And I have written why I have done this and that in this why I have coded, and why I have drawn statistical graphs and plots, and what are the results of those, and what did I understand. And before directly jumping into development of predictive machine learning models, which will directly automatically remove outliers, and sometimes it will also handle entropy and graphs and bias and variance. I wanted to show you what is actually bias, variance and errors, and how does it look like. Okay, so I've written a function so that we can see for the numerical features, that is content score and wording score, we could see what is the mean, median, mode, and also I'm using matplotlib to display histograms and box plots, and also line plots and line graphs, like that in the same similar figure. So you can see for a column called as wording, it is a numerical column. You can see the minimum value, maximum, mean, median, mode, and they are depicted in the histogram using this kind of lines. And this is the minimum value, and this is the maximum value. The mean and the median are actually colliding here, so again they're actually very thin here. And this is the mode value, it lies at minus 1.5. And you can simply see the outliers are above the quantile range over here. And if you are very interested to read what the cells are doing, and how the notebook, how fast it runs, and how many upvotes I got, and what is my position in the competition, Kaggle competition, data science competition, then you can click the notebook link below, and also give me upvotes. Yeah, appreciate me for the work I'm doing. Okay, and this is the data distribution for wording. I'm actually taking from 0.1 on the scale, and I wanted to see the positive values. And the lines are very scattered over here, the points are very scattered over here, so you can actually remove these points, but we want to see how important are these points before that we remove them. So the box plot also shows that from point 2.5 to 4, the some points are very scarce, and some points are, so many points are there. So how many points are there? So we want to see that. So also I wanted to see what is on the negative side, that is 0.01. So on the negative side you see that Like more than 50% of the data is negative. Yeah, surprising, right? Yes. And this is for the wording score. And let's see what is the distribution, the data density distribution. So why are we using data density distribution when we have 0.1 and 0.01? Because we want to see how skewed is the graph and the density. Like for suppose if I have something like right skewed or left skewed or symmetrical skewed, how close are they, and is the median value or the mean value very far, like that I wanted to see. And you see that both the median and mean value, that is the cyan, yellow and the teal, some of the median and the mean values are actually colliding. This is in teal. You can't see the median value, but you can see the mean value. So, and also for the variance, variance is actually calculated for the numerical values, and you can actually, using the variance, you can see how your graph values are varying, what is your range, what is your median, like that. And so many things are there, right, in statistics. Yeah. So so much, like using just this particular range and variance standard deviation, you can see like your range is from which point to which point, like that. And mm, like most of the data, it lies after 1 point, like before 1.07 for wording and content score. And I'm actually plotting the first, second and third standard deviation for one of the columns, that is the wording score. You can also take content score here, but I was more interested in the wording score. I wanted to see like the wording score and content score prediction is the goal of this competition. So I wanted to see how the data correlation is there. And similarly for the description, you can see like if you don't understand this, then people like me, they'll also see that is the first quantile, second quantile standard deviation, third quantile standard deviation. The value, it lies between after 0.59. So most of the values are negative, and some of the values like 50%, like more than 50% of the data, they have outliers. So we might have 50% error value. Like suppose if we have prediction value as 1.5, the real value might be actually 50% error. So we have to remove our outliers. That's what our first quantile, third quantile is telling over here, 25th, 50th and 75%. So let's include also in the comparing data, we see like in the first like whatever score is greater than 1, then that is actually a positive true score. And you can see in the pass percentage, and some of the wording scores are not, like I'm actually taking the head value for 10, so that's the reason everything is true. I have sorted it according from true to false previously. And let's compare the negative and the like the numeric and the categorical values. Categorical values, I mean the unencoded string values. Yes. So pass is very important. So pass is actually tells you if a student has passed or failed. And if the wording score wherever it was high, the students actually had a higher quantile till 3.5, and most of the students have passed in the dataset, and some of the students have failed. And I have actually tried to plot pie charts and bar charts which show you the pass distribution and the statistical plots for pass. So you can check out my previous videos as well. And in the, like while comparing numerical values, I'm using the bar chart. So you can see only 10 IDs here, and you can see 50 IDs here, but most of them are actually clubbed, and you can't see like which what, can't differentiate the values as well. So I'm scaling the data using my mass scaler, and using the fit underscore transformation, all your data keeps lying between 0 and 1. and it scales your data so that most of the scores, negative and the positive, lie between 0 and 1. And you can see that content score actually plays a major role in content score is actually higher than wording score, and that is very surprising. And the pass percentage actually depends upon the content score. That is an interesting that is an very interesting exploration. I was actually exploring the wording score till now. So I want to see the correctness of that, and I saw that there is a 56% correlation. The correctness is 56%. So you can say 40% is wrong. Yes, it might be true. So I'm actually generating a scatter plot over here, and you can see in the scatter plot that both the points are colliding, but there's no proper line to differentiate. So I've drawn a linear regression coefficient line, and you can see that most of the lines are lying above the hyperplane, and some of the outlier values are lying here, and they lie after 1.0, and there lies a value. Most of the values are between 1.0 to 2.5, and here you can see I have also developed a boarding score, content score, and the fx is actually the predicted value, and the error is actually tells you what was the difference between the predicted value and the actual value in the regression lines. And suppose if you want to use it for regression, then since we already have the slope and the bias which I got by plotting, then and the equation was something like mx plus c, and I have actually manually coded it using Python by taking a sample data frame, like from the normalized data I have taken a sample data for the wording and the content score, and actually tried to find the intercept, slope, and the bias value, like the error value. And you can check out the code, like the manual code which I have written, by clicking the Kaggle link below. And suppose if I am predicting the final score would be 2.5, then the actual score was 2, and I'm not manually coding here or hard coding it, but that's what the expected score value is. So there is a 50% difference in the scoring value. So usually after removing the outliers, you can say that the predicted value and the expected value would be same, but since we have values here, then we are manually calculating it. But what if we have the content and the wording score, and if I wanted to predict what would happen in the future? So in that kind of scenarios, then we might have to use machine learning models, so that they keep learning over our models, and they see what would be the error and the actual scores and the predictor scores, and they also try to guess the exact value of the expected values. So we will be doing that in the next few videos. And I have also written few summary and about why is correlation, regression, normalization, standardization used in this particular notebook. So you can click on the Kaggle link below and like copy and edit my notebooks. And also don't forget to upload my notebook over here. Like I can show you here. This is the upload button and this is the edit button. So by clicking the edit button, you can edit my notebook, and a separate copy of this notebook will be created. And you can practice statistical Python or data analytics by clicking the edit button. And by upvoting, you show appreciation for my videos. And also I stand little bit higher in the Kaggle competition. So this is a competition data science notebook for the CommonLit student evaluation competition. So don't forget to actually give a try and also participate in the data science competition. And you might also learn how to plot data and also write code. It might be very useful to back data analyst jobs, and also show why was data deleted in the data engineering profiles. So don't forget to subscribe and like my videos. And if you want any more videos, then leave in the comment section what kind of videos would you like to see. Okay, thank you. Good night and good morning if you're on the other end. Okay, bye bye.